Welcome in, everyone. Happy Monday. Happy Monday. Double tap that screen as you come in. We are going to be doing GED math. So if you know anybody that did not graduate high school and they have to take the GED test, and they're struggling with the math to pass, please share this live out with them. I hope everybody had a wonderful weekend, and we're going to get to it. All right, so number 1 says convert 20/3 into a mixed number. And so whenever you want to change an improper fraction, because this is an improper fraction, it's when the top number, which is called the numerator, is bigger than the denominator, you just divide, okay? So the bottom number goes on the outside of your division bar, and then the top number goes inside, okay? And then we have to ask ourselves, 3 times what? How many 3s can fit into 20? So we would say 6, and then 6 times 3 gives us 18. And then we would subtract 20 minus 18 is 2. And this is our remainder. So to write this as a mixed number, we're going to take our remainder and put it over 3, what we divided by. So 6 2/3 is our answer. Okay. Any questions on that one? Welcome in, everyone. Welcome in. Happy Monday. All right, let's do number 2. So we have 1/6 plus 7/12. Remember, whenever you're adding fractions, you have to have the same denominator. So what do we need to multiply this 6 by in order for it to be the same denominator as this? Can you put it in the chat? What do we have to multiply it by? Hey, Dread. If you need help, email me. 2. Good, you guys. Hey, Lacombe, welcome back. 2. Okay, so good. 2. And then remember, we're multiplying. So 1 times 2 over 6 times 2 is 12 plus 7/12. And then we add our numerators and our denominators stay the same. So 2 plus 7. Okay, 2 plus 7 is going to give us 9. Now we got 9/12. Can we reduce this? Put a yes or a no. Can this be simplified? Yes, Tyler, I do help with algebra. Let me put my email on here. So if you're looking for tutoring, email me here, okay, you guys? impactmath19@gmail.com. And I'm getting 3 yes by 3. Victoria, womp womp. Yes, let's go. So we can divide out 3 top and bottom. And 9 divided by 3 gets us a 3. And 12 divided by 3 gets us a 4. And that is our simplified answer. Beautiful. All right, let's talk about number 3. We want to subtract fractions. Remember, we have to have the same denominator. So this is usually where people struggle. So what number can 4 and 6 both go into? What's our LCD, our least common denominator? Can you guys tell me? Somebody said 24, LCD 2. Okay, so I see what you guys are multiplying. 24, 12. Destiny said 12. Good. Okay, so 12 is our LCD. Now that we know that we both want them to be 12, that's when we can ask ourselves, what are we multiplying this by to get 12? I saw a lot of 2s, and then I saw some 3s. So wonderful, everybody. So 3 times 1 is 3, minus, don't forget to drop down that sign, and then 1 times 2 is 2, and we get 1/12. And that is our answer. Now, I got a question for you guys. Do we need a common denominator when we're multiplying fractions? Put a yes or a no in the chat. Do we have to have a common denominator when we multiply? Yes or no? Sean said no, 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 no. Good. No, no. Wonderful, you guys. Never when we multiply, only when we add and subtract, right? So perfect. So now what we can do is we can just multiply straight across. But I always try to teach my students to give them less work. If you get good at cross simplifying right away, it just saves you a lot of work. Especially if these numbers start to get big, it's going to save you. So what can we cross simplify here? Put it in the chat. What can we cross simplify? Thank you, Lucky, for sharing the live. Thank you, thank you. Luke's mom. Luke's mom. Sorry, I'm murdering your name. But thank you for sharing the live. 1/3. Hey, Assassin Wolf. Hello. Did your semester end well for you? I know you were in calculus, right? 3 and 6. Elizabeth said 3 and 6. Wonderful. And I see a lot of people giving me answers. Hello, Alex. Hello. So 3 and 6 is what we can cross simplify. So we can divide this by 3 and we can divide this by 3. This is going to go to a 1 and 6 divided by 3 goes to a 2. Now when we multiply, we don't have to think about reducing after. So 1 times 5 gets us 5 and 4 times 2 gets us 8. And that is our simplified answer. Great job, everybody. Any questions? So we converted an improper to a mix, added, subtracted, and multiplied. Now we're going to get to some division, right? Got to do some division. Thank you for the double taps. We're at 1.K double taps. Thank you, thank you. Can we keep on going with the double taps? Let's try to get to 15. Thank you, thank you. I see those double taps coming in. And let's continue. Now with division, keep, change, flip. Oh, you're already on it. You already on it. Yes, let's do that. Keep, change, flip, right? We can't divide fractions, but we can keep them, change them, and flip them. We can change this to multiplication. We keep this left side as 3/4. We change this division sign to times, and then we flip. Or some people call it the reciprocal, okay? You might hear that word. That just means you flip the denominator with the numerator, okay? So it's going to become 6/5. Okay. Now, some people are going to say, oh, I'm just going to multiply right away, which is fine. But I want you to start getting the habit. Can you cross simplify? Put in the chat what we can cross simplify. Put in there what can we cross simplify before just multiplying straight across. Thank you for the follows, love. Lacombe said 4 and 6. Yes, 6 and 4. Beautiful. Oh, I'm teaching my second graders fractions right now. I love it. Hopefully they're grasping the concept, understanding. Hopefully you got some what do they call those? Manipulatives. Hopefully you have that so they could practice especially for the hands-on people. So we're going to divide this by 2 and divide this by 2. And so 6 divided by 2 is going to give us a 3. And then 4 divided by 2 is going to give us a 2. Okay, now we can multiply. 3 times 3 is 9. And then 2 times 5 gets us 10. And so this is 9/10. 6 and 4. Why not 3 and 5? Okay, great question. So why not 3 and 5 is because 3 and 5 have nothing in common. So this is a prime number, this is a prime number. And prime numbers usually don't have anything in common. But see, we had both of these were even numbers, and every even number can be divided by 2. That's a divisibility rule. So the divisibility rule says if it's even, 2 can go into it. Great question. Okay. And that way, so when you cross simplify it out, you don't have to worry about reducing it after. Because when these numbers start to get big and you're multiplying bigger numbers, that's a waste. That's wasting your time, especially if it's a time test. So if you can get in the habit of cross canceling out before and then multiplying smaller numbers, it will help you. Yep, you're so welcome, Alex. Yep, great question. All right. They gave us some mixed numbers here. So what do we have to do if we want to multiply mixed numbers? What do we have to change this mixed number into? Oh, thank you, Alex. Thank you, Arts, for sharing out the live. Make a common denominator. So we never have to make a common denominator when we're multiplying, only when we add and subtract. So times the 2 and the 3. Yaya said 7 over 3. Good, Yaya. Improper fraction. That's the word that I was looking for. We have to change these to improper fractions. And how we go about that is we multiply, then add. So I'm going to just write it out for people that need the extra steps. So we're taking our denominator, we're timesing it by our whole number, and then we're adding that to the numerator. And that goes all over the same denominator, okay? We're going to keep our times, and we're going to do the same thing here. 5 times 4 plus 2 over, what are you dividing by? 5. All right? So now, remember, you got to go order of operations. We cannot add before multiplying. So we do 3 times 2, which is 6, right? 6 plus 1 gives us 7/3 times 5 times 4 is 20, plus 2 is going to be 22 over 5. Okay. Can we cross simplify anything? Yes or no? Can we cross simplify here? No. Good. No, we don't have even over even, right? And we have prime over prime. Nope, can't do anything. So now we do have to just multiply. So 3 times 5 is 15. Somebody please do this for me. What's 22 7 times? What do we get when we do 22 times 7? Yeah, said 154. Carol, hey, Carol, Happy New Year. 154, thank you. 154, yes, you guys. So a lot of you guys are saying 154, so I'm going with that. 154. All right. Yeah, because 7 times 2 is 14, carry the 1. Yep, perfect. All right. Now, usually when you're taking, like if they have you multiply mixed numbers, usually your multiple choice is going to be in a mixed number form, especially like if you're taking the HESI, or like the ASVAB. We might have to change this back because our multiple choice might be in, mixed number form. So let's just do that. Let's just practice it, right? It won't hurt us. So if we do 15, I'm going to move it up because I think we might need more space. If we do 15 into 154, right? 15 can't fit into 1. No, 15 can fit into 15. How many times? 1 time. And 1 times 15 gets us 15. And then we subtract. Okay, this gets us 0. And then we drop down that 4. Well, can 15 fit in the 4? No. So then you have to put your placeholder 0 here. And 0 times 15 is 0. We subtract. We get 4 minus 0 is 4. This is our remainder. And so we write 4 over 15. And this will be our answer as a mixed number. Any questions on that process? 10.2. Good. Good. Yes. 4/15. Good. This is, of course, if you don't, because on the GED, you have like 5, or there's a few questions that you cannot have a calculator on, and then the rest of the test you'll have a computer calculator. I just realized I forgot how to write out long division. I love it, and a lot of people, Jamie, you ain't the only one. There's thousands, trillions of people that when you don't use this stuff, it just leaves you, especially if you get to use a calculator. It's like, how did I do that again? So I totally feel you on that. All right, let's go to number 3. To the nearest thousand, what is 3,400? How can we write that? To the nearest thousand. Put your answers in the chat. Let me see them. Oh, okay. Caitlin. Somebody said, Carol said 3,000. Rizzy said 3,000. Okay. Janessa, Stacy, 3,000. Letta. I love it. So y'all getting 3,000. Okay. Latia said, I don't know. Good. Okay. So when you're rounding, this is all about place value. So let's recap for the people that forgot. Okay. I'm going to recap place value up here. So you have a decimal. And then this is your ones. Okay. Tens. What comes next, you guys? Put it in the chat. What comes next in our place value? What comes next here? Hundreds. Good. Yes. Hundreds. Then thousands. Then here is 10,000s. Oh, thousands. And then we have 100,000, millions, okay, so on. But I don't think we're going to the million on here. So we go to what they said. We want to round to the nearest thousand. So since this 3 is in the thousand spot, we have to look to the right of it. And since this is a 4, this stays the same. So this number that we're rounding to stays the same, and everything after this place value goes to a 0. So that's why everybody was saying 3,000. Beautiful, you guys. Beautiful. Oh, you guys can't see the whole problem? I tried to put it up. Oh, okay. Yes. Can you guys see it now? Is it a little bit? Okay, let's go to number 4. To the nearest thousand, what is 3.46? To the nearest tenth, I meant. To the nearest tenth, what is 3.46? Good. Mia said 3.5. Oh, thank you, Amanda. Nicole said 3.5. I love it. Oh, good. 4? Okay, so let's talk about that. Okay, remember the tenths. So we're going to go back up here. The tenths, whenever you have that TH, is after the decimal. So this is very important, you guys, especially in those who are into crypto. Because crypto deals a lot with this end of the spectrum, especially if you have a new coin coming out. It's really going to be like, so tenths, hundreds, right? Hundreds. And then you'll have thousands. Do you realize there's no once? It starts right away with tenths, then hundreds, then thousands, then 10,000s, and so on, okay? So we have 3 ones and 4 tenths. So this is what we're rounding to. Remember, we look to the right. Since this number is above 5, we know this has to go up and everything before it stays the same. So 3.5, and then this number goes away. You could write 0, but since we're rounding to the 10th, we're just going to leave it at 3.5. Okay. All right, let's do number 5. To the nearest 100, what is 566 rounded to? Let me see it in the chat. Carol, I see you. Okay, Mariah, Theodore, 600, 600, 600. Yes, 600. Good. Because 5 is in the 100 spot. We look to the right of it. It's above 5. So this makes it go up 1 to a 6. Everything that follows goes to a 0. So 600. Beautiful, you guys. This is another one that trips people up. What is $432.70 rounded to the nearest dollar? So if we want to round this to the nearest dollar, let me see it in the chat. 433, 433, 433. Okay, somebody said they still don't get it. Which one didn't you get, love? 433. Good. Okay, y'all good with y'all money, huh? Thank you so much for the gift, hun. Thank you, thank you. Okay, so $432.70 to the nearest dollar is going to be 433. So when you see to the nearest dollar, remember this 2 is in the 1 spot. This is 1 spots is always dollars. So the terminology is like, that's what kind of throws people off. So dollar, think of ones. And since we look to the right, this number is above a 5. This goes up by 1. So 2 plus 1 is 3, and everything else goes to 0. But everything before it has to remain the same. That's why we're writing 4-3. Okay? Any questions on this part? It looked like a lot of people got it, but any questions? Thank you, you guys. We are at 5.5K. Double taps. Thank you. Thank you for the follows. Thank you for the gifts. So would the bottom question be 5.0? Okay. So let's talk about that, Latia. Great question. So for number 7, it says, what is 4.80 to the nearest hundredth? So where is the 100th spot? Let's put it in the chat. What digit is in the 100 spot? The 0. Yes, the 0 is in the 100 spot. Correct. So when we look here, see how there's no number after it? So since there's not a 5 or above, everything remains the same. So it's just going to be 4.80. And this, yeah, that's a trickery. So hundreds is in the 0. We look to the right. Nothing's after it. So it has to stay the same. Great question. Great question. Now, to get your answer, Latia, if it said round to the nearest ones, and this had or to the nearest dollar, right? If this one said to the nearest dollar, then your answer would have been 100% correct. It would have been 5.0. Okay. If it would have said dollar here. All right. Great. Okay. Let's keep it pushing. Okay. So we're ordering these. You guys might not be able to see over here. Sorry. My book is just too big. So, but we're going from least to greatest. Okay, so that's what we're doing here. We're listing these from least to greatest. All of these, okay? I'm going to put it right here so everybody can see. Least to greatest. Okay. All right. Fractions, right? Are we dreading them? Are we like, oh no, what is this? Is that how we're feeling? Or do we love fractions? I'm like a mix. So, How I would do this is, for me, I change mine into decimals and then I rearrange them that way. That's easier for me. So 2/3, there's some fractions that you just have to have memorized, especially if you're taking a standardized test, the GED, the ASVAB, HESI, TEAS. There's just some fractions. If you have those memorized and you can go back from fraction to decimal, it will save your life. Okay. So what do I mean by that? 2/3 is always 0.6. It's 0.666 repeating. Okay. 3/4. Think of 3/4. How much is 3/4? Well, 3/4 is 0.75. Okay, well, if I'm splitting $5 in half between me and my brother, and we going to the store, how much am I supposed to get? How much he supposed to get? Put in the chat. How much are we splitting for $5? Good. Carol, yes, 250. Exactly, Alex. Yes, let's go. $2.50 we each get. Now, this one is a little bit challenging for me, right? Because I don't know what 4/9 is off the top, but I know it's close. Like if this was 8, this would be close to like 0.5. So it has to be a little bit under 0.5. So I'm guessing it has to be like 0.4 or somewhere around there. Any questions on how I guess this? I don't know if it's, does it come out, Carol, does it come out 0.4 exact? Oh, nice. But did everybody see how we calculated that? So I said, okay, if this was 8, this will be 0.5. This is less than a half. So I'm going to just go 0.4. Yeah, somebody said we need a cheat sheet. Yeah. So fourths, really, if you have fourths and thirds memorized, halves, most, like if you want to try to take halves of any number, think if you put money towards it, most people can do halves. When you think about splitting $5, $3, think about splitting. But this is where it comes out a little funny, right? But if you're not good, right, with that, just divide it. Take the time to divide it real quick. So you would say 9 can't fit into 4. So we're going to put a 0, right? And we'll put 0, drop down. And then we drop down 4, drop down to 0. Well, how many 9s can go into 40? Well, I would say 4 can. 4 times, because if I do 5, that's 45. That's too big. So 4 times 9 gets us 36. And then we don't care after that because we know it's like 0.4. Okay. So now, if we know that this is 0.4, 0.75, 2.5, and 0.6, we can know which one's the smallest. 0.4 is the smallest, then 0.6. So we could write 4/9. Okay, so that's gone. 0.6 is the next one. What comes after that, you guys? What's next? Put it in the chat. What comes next? Good. I'm glad you got it, Laura. 2/3. Carol said 3/4, 5 seconds. Oh, thank you, Alex. Thank you. So we got 3/4 and 5 halves. Perfect, you guys. And that's from least to greatest. Good. Great. Latia, beautiful. Yes, let's go. Okay, so now number 2. Now, number 2 is about place value, but it's also about knowing your negatives too, right? So, okay, we already have it in decimal, so that's a good thing, right? Which one of these is the smallest number? Put it in the chat. Which one is the smallest? Negative 0.03, negative 0.3. Negative 0.03. Oh, we're going back and forth between these. You know what's tricky about integers? Because these are called integers, okay? Well, actually, they're not. Sorry, I'm misspeaking. They're not integers. They have to be whole numbers in order to be integers. But what is these rational numbers? What is tricky about them is when you think about a number line, you have to think, so this is 0, right? Okay, go wake up daddy. So here goes a number line, right? Now, if we plotted these on a number line, which one is coming closest to 0? Is negative 0.30 closest to 0 or negative 0.03 closer? Well, this would be negative 0.03. Then this has to be negative 0.30 out here, because before we can get to negative 0.1, this is going to be in between there. Does that make sense, you guys, or not really? When you see it on a number line, does it make sense? Does that help you? Okay, good. Kia said yes. Yes. Okay, good. So I always say, if it helps, if you're a visual person, draw that bad boy out. Okay, so now I can see, oh, this is way farther from 0. So I'm starting with negative 0.3. Then I'm going to negative 0.03. Okay, this is gone. This is gone. Okay, what comes next? Put it in the chat. What comes next? .031, 3.3, 3.29, 3.031. Oh, we kind of all over the place with this one. Okay. So let's look at it. So if we think about this as money, right? This is 29 cents. This is 30 cents. This is 3 cents. So would you rather have $3.03 or $3.29? Which one is bigger? Well, this is smaller. Yes, baby? Okay. Thank you, baby. So this actually would come first. Yes, you can.
Okay, give me one.
Go ahead. Go get it. You got it.
That's scary.
It's not. And then 3.29. And then 3, because 29 cents is smaller than 30 cents. And then it will be 3.3. Because this is like, if you add a 0 there, you can see it's 30 cents rather than 29. So this is how it would go. And for my stock people or my people that look at crypto, this is where you start seeing these numbers at, right? Not so much this, but you'll start seeing stuff like this. And it's like, what? And if this move up to the 10 spot, 10 times your money, it's just all good, right? Love to see it. Man, Bitcoin's going off today for my crypto people. Y'all saw that? It's at 102, 103K. I'm going to get in your live every day. I have the tease test scheduled next month. Let's go, Kia. I'm going to be here Monday through Saturday at 1 o'clock Central Time. Yes, Steph, you got to love the children. All right, let's do number 3. So we're going from smallest to greatest. All right, so what should we do first? All right, so -3/2 fractions to decimal. I love that. Let's do fractions to decimals. So 1/5. Okay. How I memorized my fifths was, think about $100 bill. And it's divided. How many 20s does it take to make 100? Well, 5 20s. So if this is 1/5, that means this has to be 0.2, because 25 times makes 100. So 1/5 is always 0.2. Okay? That's how I remember my fifths. Think about a $20 bill and 100. If that makes sense, great. Okay? Remember, we're splitting $3 in half. We're going to the store, me and my sister. How much do we each get? Put it in the chat. How much do we each get? Good. -1.5. Beautiful. Good. So -1.5. Okay. Now 1/3. Does anybody know what this decimal is for 1/3? Monica, yes. Carol said 0.333. Leslie said 0.333. Yes. Rappy, yes. So 1/3 is always 0.33. And that's why we say 2/3 is 0.6, right? So 1/3, 0.3, just double it for 2/3, be 0.6, okay? That's how you can memorize those. Now, we should be good and going. We got everything into decimals. What is our smallest decimal? Put it in the chat. Is it -0.4 or -1.5? What's our smallest? Thank you, Kate, for the follow. Okay, -0.4, -1.5. Many want to put 0.33. Don't remember. Yep, you got those negatives. -1.5, -0.4. Ooh. Okay, so let's draw out that number line, right? Slap a 0 right in the middle. Now, remember we're on the negative side. Does -$1.50 come before 40 cents? No, so this would have to be the closest to the 0. Then this is -1.5. Because if we have -1 right here in the middle, this has to be -1.5. And then before you can get to -1, you have to have 40 cents. Do you see it now? For those who are saying this one, does that make more sense? So really, the farthest away from 0, this is the least. So -3.5. Then we go to -0.4. Okay. What are we doing after that? What comes next? Let me see it in the chat. Good, good. Carol said 1/5. 0.3. 1/5. Bridget said 1/5. Okay. Be careful because this 0.3, right? We got a 0.2 before a 0.3. So 0.2 has to come before 0.3. So 1/5, right, is going to come before. Then what comes next? 0.34 or 0.3? Good, good, Hill. Nicole. Carol said 1/3, 0.3. Good. 1/3, 0.3, 0.3. Beautiful, you guys. You guys got it. Because remember, this is like 0.33333 repeating. But so we would have 1/3, and then 34 cents is bigger than 33 cents. So then we have 0.34. And that's how we do least to greatest. Wonderful. Wonderful, wonderful. All right, let's go to the next. Let's go to the next. So now we have some integer work that we're going to be doing. And so thank you so much for the gift. Thank you. Thank you. I got to remember the number line. Yeah, that really helps. Slap that 0 in the middle and then place those numbers. Yeah, Alex said, ooh, love, hate them. Yep. Okay. So we have 5 plus -3. Let me see your answer in the chat. What's 5 plus -3? Thank you, Leslie, for the rose. Thank you. Thank you. Thank you so much, Jess, for the rose. Carol said 2. 2 is number 1, 2. Good. Yes, number 1 is 2. 5 minus 3 is 2. Perfect. Okay, let's go to the next. -4 plus -7. Let me see our answers in the chat. Yeah, these always confuse me. They confuse a lot of people. Good, I see those -11s coming in. I see positive, negative. Yes. Okay, remember, we're adding. So since we're adding, the negative has to stay. Okay. So -4 minus 7, somebody owes you $4 and they say, can I borrow 7 more? Well, they're going to owe you. That's why we keep the negative, $11. Okay. 3, 6 times 3, 18. Number 4. Can I see your answers in the chat? -2 times 6. What do we get? -12, -12, 302. Yes. -12. Everybody's remembering their negative. Wonderful. A negative times a positive is a negative, and we do get 12. All right. Number 5. We have a -3 minus 2 plus 6. What do you guys get for this one? Carol said 1. 302 said 1. 12. 1, 1. 1, 1, 1, 7. Ooh, okay, so let's check it out. So somebody owes you $3. And then say, oh, can I get 2 more? Well, they're gonna owe me a total of $5, right? But then I have plus 6. So -5 plus 6 is the same thing as saying 6 minus 5. 6 minus 5 is a positive 1. Thank you, Case, for the roses. Thank you, thank you. Good, you guys. All right, let's keep it pushing. 10, half a 10. Half a 10 is 5. Okay. What do we get for number 7? -5 times a -2. Put your answers in the chat. What do we get? 10, 10, 10. Beautiful. Good. Remember here, a negative times a negative is always a positive. So it is going to be a positive 10 there. What about number 8? -21 divided by -7. What do we get for that? I see the 3, 3. Thank you for the share in the live, love. 3, 45, 3. Good. 3. 21. Okay, a negative divided by negative is a positive. And then 21 divided by 7 is 3. Okay. For number 9, we have a positive 12 divided by a -3. What is our sign going to be for this one? Is it going to be a positive or negative? Put it in the chat. Am I putting a positive here? Am I leaving a positive or negative? Negative, negative. Good. Yes. Positive divided by negative is always a negative. Good. Easy peasy. All right, let's keep it going. Okay, now, of course, we have some absolute value, right? You're going to see this on the GED. Now, does everybody know what absolute value? Can we talk about what absolute value means? So what is the absolute value of 4? What is our answer for that one? Thank you for the double taps. I do see them coming in. Can we get to 10K likes, please? 4, 2, 2. Good. It's a positive 4. Good. So absolute value means if you have a negative or a positive that comes out, it comes out positive. So this will, number 1 will be 4. Number 2 is going to be, what's the absolute value of a negative 7? 4, 7. Good. Good. 7. It's going to come out positive. So remember, the absolute value makes it come out positive. And if it is already positive, it stays positive. It does not come out. It's, absolute value is not opposite. Don't put that in your head. It comes out always positive, okay? So let's look at number 3. 6 minus 2 is 4. Remember, we still have the absolute value on it, but it's going to come out 4. Okay, can you guys put your answer in for number 4 in the chat? We have 3 minus 5. What's the absolute value of 3 minus 5? Good, Carol. KB, yes. Wow, you guys are coming with it. Okay, I see a negative 2, a negative 2. Okay, we're going back and forth between negative 2 and 2. Okay, so 3 minus 5 is a negative 2. But you never took the absolute value. You just did 3 minus 5. Remember, this, you have to drop down the absolute value. Then the absolute value of a negative 2 is a positive 2. Any questions on that? Oh, okay, good. Yes, okay. Yep. Good. I'm glad we're going through this, you guys. Clear up all the misconceptions. Wonderful. Thank you guys so much. We made it to 10.4K likes this live. I appreciate all my double tappers. Thank you for all your comments and your shares and your gifts. Thank you, you guys. Let's keep it going. So number 5 says the absolute value of x equals 10. Is absolute value always positive? Well, when you have numbers like this, well, it depends because they do some trickery ones. But when examples like this, yes, it will always be positive. But let me show you when it comes to an equation. Remember, absolute value is the distance from 0 in both directions. So what do I mean by that? When we have the absolute value of 10, it's going to say x equals a positive 10, or x can equal a negative 10. Because absolute value is the distance from the negative side of the number line and the positive side. So that's why it equals, when it comes to equations, you have 2 answers. Yes, Alex, yes. Thank you for the gift. Thank you, thank you. So we have a negative 10 and a positive 10. So again here, how many answers are we going to have for this one? Thank you, Ann, for the rose. Thank you, thank you. Two. Okay, good. Repost Master said 2. Beautiful. So, wait, do x equal 1? Wait, do x equal 1? No, so there's a 1 in front of, but x equals to 10 and x equals to negative 10. Those are the answers for x. So when we write this, we're going to write y minus 9 equals a positive 5, or to get the other side, we write y minus 9 equals a negative 5. So you have to set both of these equations equal to a positive and a negative. And then we solve. Okay. Bridget said 14 or 4. I love it. 4 or 14? Beautiful. Okay. So how do we get y by itself? We have to move this negative 9 to the other side. We're going to do that by doing the opposite. So we're going to add 9 to both sides. We're going to drop down our y. 5 plus 9 gives us 14. Same thing over here. We're going to add 9 to both sides. But we get y equals what here? What does this give us when we combine those? Thank you for the gift, love. Thank you, thank you. 4, 4, 4, 4. Good. You guys are seeing? Negative 5 plus 9 gives us 4. Beautiful. Good. And that's how we do absolute value. Okay. All right. Okay. Now, you know the word problems are on the GED, right? We got a lot of word problems for the math section on the GED. Okay. So, I'm trying to see if you guys can see it all. Okay. Here, yeah, if I move it over here. Let me see if I can lift up my thing a little bit more. Hold on just a second. Sorry, you guys. Okay, can we see it? Yeah, Martha said, OMG, I almost failed the GED to math. It's most challenging for me. Yep. A lot of people have that last math test to pass when they're trying to pass the GED. Because you know you have 4, well, for those who don't know, you have like 4 tests you have to take. Okay, thank you, Repost, for the gifts. Thank you, thank you. Can you guys see it better now? Can everybody see all the question? As much as possible. Okay. It may. Jesse, I gotta try that next time. But then I'm wondering, does it look weird on your guys' end when I do it vertical? Because you know how like YouTube, you do videos vertically, but then I thought like with TikTok, you have to do it horizontally. But I will most definitely try that next time. So thank you for that advice. Hey, Jacinda. Hello. I'm doing good, hon, on a Monday here. Like I said I was going to be. Trying to be consistent. All right, so let's look at this one. I hope you're having a great day. Thank you, Jacinda, so much for the 2025, hon. Thank you. All right, so what expression represents 7 less than the product of 10 and a number h? Okay, so let's talk about this. If we want 7 less than, A and B are totally out because this is 7 minus. See, in order for it to be 7 less than, 7 has to come after the minus sign. So just by us knowing less than verbiage, that this 7 is going to be last, that help us narrow it down to 50-50 chance. Any questions just on that part? Good. So we have C. Okay, so we got C. Okay, then another key word here, product, right? Product means times. Oh, it's making me, hold on, you guys. It's making me reset the live, else it's gonna cancel on us. Let me reset. Okay, we should be good. Okay, so now product means times. So 10, so this times is going to go in place of and. So 10 times h minus 7. And like you guys said, C is our answer. By just you knowing product mid times, you know it couldn't be D because D is a quotient or divide. They could have used a quotient or divide. The quotient of 10, okay? So this is really vocabulary that they're trying to test you on, okay? Let's go to number 2. What is the greatest common factor of 12, 24, and I'm going to write it right here in case you guys can't see it, 48? Okay. So what is the greatest common factor? Does anybody know? Let me scoot it over. There. 12, 12, 12. We're getting a lot of 12s. Good. Remember, we're looking for a factor, and we're looking for the greatest one. So although 6 and 8 can go into all of this, remember, well, 8 can't go into 12, so that's how we know that one's out anyway. But 12 can go into 12. 12 can also go into 24, and 12 can go into 48. So C is going to be our answer. 48 was too big because 48 can't be a factor into 28. Into 12. See, 48 can't fit into 12. That's how come we know this is too big. And then this didn't work, right? 8 didn't work because it doesn't go into 12. So really, it was only a 50-50 chance. But as soon as they put 12 and we see greatest, it has to be 12 rather than 6. Does that make sense? So this, we're not really even doing no math. We're just understanding really the vocab. Thank you, Ann, for the rose. Thank you, thank you. All right, let's keep it pushing. So again, you guys, this is for the GED, okay? GED. If it asks for the lowest, then it would be 6. They usually would not ask that. They always ask for either the greatest common factor or they ask for the least common multiple. So so that's what the terminology that the GED really uses is greatest common factor or least common multiple. Okay. Are these on the T's as well? That is a great question. I know this is on the T's. Of course, word problems are on the T's, but I'm not too sure. I can't remember if greatest common factor is on there. If anybody else is taking the T's, can you refresh me? Is this on the T's? If you're in the chat. Good. So, Stamina said 3 would be the least common multiple. Three would be the least common multiple for, are you saying for this one? Thank you for the heart, me confident. Thank you, thank you. So the least common multiple has to be a number bigger than all of these that these numbers can go into. So the least common multiple actually would be 48. So if they ask for the least common multiple, then D would be our answer. Is equivalent to a high school diploma? Yes. Yep, this is equivalent to the high school diploma, the GED. So if you dropped out, right? Because some for whatever circumstances, some people just have to drop out in life. So you drop out of high school, this is the test that you're going to take. Or they call it, in some states, they're doing the high set. I think it's called high set. It was something. But it's something it's the same thing. Is this going on YouTube? Zay, I will post this on YouTube. Thank you for asking me. I will post it, okay? I'll be thinking like, dude, people really, because I post other videos on YouTube, so, but I gotta remember, some people actually do go watch these, so follow me at YouTube if you want this Impact Math 19, you guys, over there on YouTube. And if you need tutoring, if you need help passing the GED, email me, okay? So let's look at number 3. Gina sells 5/8 of a mushroom pizza. and 3/4 of an onion pizza to the same family. How much pizza in all did the family buy? Thank goodness. Can they really do this though? Like, I thought you had to buy a whole pizza. I guess if you go to like a pizza buffet, but then I don't know. It's like, what they be coming up with some crazy problems, right? Like, who would buy 5/8 and 3/4? I guess if like you getting a specialty pizza, but whew. So how much pizza did the family buy? So what do we have to do with these two numbers, you guys? Put it in the chat. What do we got to do with them? A, laughing out loud, pizza by the slice, laughing out loud. I guess you're right. Pizza by the slice. But I'm just thinking like, your common, what do you get? Pizza Hut or Domino's? You ain't buying no 5/8. Common denominator. Add them. Good. Beautiful, you guys. Yes, we are adding these. So we're going to do 5/8 plus 3/4. Okay. Remember, whenever we add fractions, we have to have the same common denominator. So what do we have to multiply this by, top and bottom, in order for it to be the same denominator as that? Put it in the chat. What do we have to multiply it by? 3/4 turns to 6/8. 2. Good. 2. Yes, 2. So 3 times 2 is 6. And 4 times 2 is 8. Good. Same denominator. Keep that 8. Now, let's look here. There's only one answer that has an 8. Everything else doesn't have an 8, right? So by these having a 32 and 12, I'm like, that's out. Now I could have a 50-50 chance here. I'm not going to actually just rule this out because I don't know what this is yet. But I know it's between here and here. Now 6 plus 5 gets me 11. As soon as I see this 11 over 8, I'm going with A and I'm going to the next. Especially if it's a timed test. They gave you only one problem that had an 8. This is what we love when they help us out like this, right? Good. Okay, now let me show you how this becomes this. Okay, let's talk about how this becomes this. So we have to change this to, this is called an improper fraction, okay? All that verbiage, because sometimes they're going to use this. All that means the top is bigger than the bottom. The numerator is bigger than the denominator, okay? And when you want to change this improper fraction to a mixed number, because that's what this is a mixed number, we divide this. So we take 8 on the outside, the denominator goes on the outside, the numerator goes in the inside. And then we ask ourselves, how many 8s can fit into 11? 1 8 can fit into 11. So 1 times 8 gives us 8, and then we subtract. 11 minus 8 is 3. That remainder goes on the numerator, and what we divided by goes on the denominator. And that's how they get 1 3/8. Any questions there? Thank you for the follows. Thank you for the double taps. Can we just make it to 15K taps, please? Please. 1 3/8. Good. All right. Okay, some more crazy word problems, right? Thank you guys so much. We made it to 15K. Thank you. All right, so Catherine has 5 4/5 yards of red silk fabric. Steve uses 1 1/3 yards of it. How many yards of red silk fabric are remaining? Fabric. Ooh, I don't know why that word is like hard for me today. Oh, good, bad. Just be up in here. So what we doing with these two mixed numbers? Good. Nicole says subtract. That's exactly what we're going to do. We're going to subtract these two because we started off with a total and then we want to subtract it, what he used, right? So turn the first one into 29 over 5. Okay, I love it. So are we going to do it that way? So 5 and 4/5 minus 1 and 1/3. Now, we can do it what you're saying. We could change this to an improper and then subtract. And then once we do that, we have to divide it back and get a mixed number. Or we can come up with the same denominator. So what does 5 and 15 both go into? Put it in the chat. What do they both go into? I'm going to write it right here. What do they both go into? What's 3 and 5? 15. 15. Good. So we know we want this to be 15 and we want this to be 15. So that now we have to ask ourselves, what and what? What are we multiplying top and bottom? 3 times 5. Okay. So we get a 5 here. And then 5 times 3. Okay, so 4 times 3 gets us 12. And then if we have a 5 and a 1, and now we can subtract. 5 minus 1 is 4. So I automatically know A is not going to work. Okay. 12 minus 5 is a 7. I'm using my answers as I go. Well, I have a 7 here. Same denominator stays the same. C is my answer. So, the person that said, let's change it to an improper, you were perfectly correct, right? That's how your brain saw it right away. But sometimes it's more simpler if you just do your fraction rule, like come up with the same denominator, keep it as mixed number, and then subtract. You'll get there quicker. Does that make sense? Where did the 15 come from? Good. Okay, so the 15, how did we get the 15? Good. Okay, so we got the 15 by knowing our LCD. So what we said is, okay, we need our same denominator. So 3 times 5 gets us 15. And that's how come this had to be a 15 and this had to be a 15. So the common denominator, whenever you have a prime and a prime, like a 3 and a 5, you just have to multiply those. And that will give you your same denominator. Great question. Jeremiah, thank you for the follow. Yes. Goofy, yes, you just multiply them. Oh, okay. Yep. And we just multiplying them because they both prime. So that's the only way we could do it. Great question. Any other questions? What time is it? Let me see. Okay. All right, let's go to the next. Okay, beautiful. Thank you for the double taps, you guys. We're at 17.2. If we can make it to 20K, you guys, thank you. Okay, number 2. Put the following numbers in order from least to greatest. Okay, remember we practiced this. Okay. If you were here from the whole time, we did a couple like this. So we went from smallest to greatest. Remember, we changed all our fractions to decimals. So if we're splitting $3, remember, we going to the store, mom gave us $3. How much are we each getting to spend? $1.50. Back in the day, you could get a whole bunch of candy if you went to 7-Eleven. Back in the back day, right? Now, this can't even buy you a pack of M&Ms. It's like $2 and something for some M&Ms, man. The good old days, right? Or am I telling my age? Good. So Bridget said, true, Papa. Okay, good. Papa know what I'm talking about. I know $1 for chips. Jacinda, yes. Okay, so Bridget gave us our answer. So, so we want the smallest, right? So this big old 15, we know is going to be at the end. Then $1.50 comes next. Now it's like, which one goes first? This one or this one? Put it in the chat. Which one are we writing first up here? What are we starting with? This or this? Which one is smaller? Okay. Jamaria said 1.0005. Nicole, good. Leslie, yes. Let's go. So the more zeros you got, the farther this number, the smaller this number is. 0, 0, 0, 5, and then 1.005. Now, this is what we would hope for. If I'm talking to all my crypto people right now, right? We would hope you would get in here and then go here, okay? Because you done, how many times did you X your money?
Mommy,
Oh, just 1X, 110X?
I watched it.
No people. Go watch that.
Mommy, who was one song?
You don't watch Sonic? Okay. So 1.005, 1.005, 1.5, and then, we shouldn't put 1.5 here. We should really write 3/2, right? Because you got to keep it in that language. But that would be our answer. All right, let's do this one. Put the following list of fractions and decimals in order from least to greatest. And be careful here because sometimes they be switching on you. They be going from greatest to least to greatest. So really pay attention to this part, okay? Don't get just going from smallest to greatest. Because sometimes they switch it up. All right. Remember, 2/3. 0.6. Always 0.666. I don't know what this is. 8 divided by 5. I have no idea what this is as a decimal. I know this is negative 1.6 here. But 8/5. Okay, let's think about this. Okay, this is 10 would give us close to a half if this was 10 up here, but it's like 2 down, so it has to be smaller than half. So I'm guessing it's going to have to be like a 0.3 or something like that. What we could do is we could just divide it real quick. We could do 5 into 8. Oh, no, it's not 0.3. It's way bigger than that. I'm tripping. 5 into 8 goes one time. It's going to be like 1 point something. 1 times 5 is 5. Subtract 8 minus 5 gives us 3. Okay, and then this comes out as 3/5. But remember the rule for fifths. Think about a $20 bill. Because there's 5 20s that make 100. So if you have 3 20s, this is going to be 0.6. So this is really 1.6. So fifths, always think about 20s. And so if you have 3 20s, that's 60. Okay, that's how I remember that. Okay, 3 20s make 60. All right. Okay, now, let's start, right? What's our smallest? This or this? Put it in the chat. What's smaller? This or this? Carol said negative 1.7. Beautiful. Negative 1.7. Good, you guys. So that's our first one. Negative 1.7. Thank goodness they only gave us 2 that were negative, so we know this has to come next. Negative 1. It's negative 2/3, right? We want to keep the same verbiage. So this is gone and this is gone. All right. What comes next? Okay, good. 0.068. 0.6? Good. Remember, this 6 cents got to come before the 60. Good. Yeah. So this is like 6 cents, or even if you round it, this is like 7 cents here. 7 cents is smaller than 60 cents. So this has to come next. Oh, wait, hold on. Yeah. So, yeah. Okay, so this is going to come next. Boom. Then is 0.6 or 0.61. Okay, remember, this is 0.66 repeating. 6666. So which one is actually smaller? Thank you, Jacinda, for the double taps. Thank you, Bridget, for the double taps. We're almost there. We're at 19.8K. I appreciate those double taps. Good. Nicole said 0.61, 0.61. Yes. This comes next. 0.61, because 61 cents is smaller than 66 cents, because 2/3, remember, just repeat 66666 forever. Okay, so then we would have 2/3. And then our last one, which is the biggest, 1.6. And we have 8/5. And that is our beautiful answer. All right, you guys, thank you so much for hanging with me today. I do have to run and go pick up my babies from school. Thank you, Reed, for the rose. Thank you, thank you. We will be on tomorrow. I think we're going to be doing maybe ASVAB tomorrow or geometry, one of them. Okay? Thank you, Jacinda. Blessings to you guys as well. Oh, thank you so much for the heart me's. I appreciate you guys. And everybody, I'll catch you on the next one. Bye.